Yeah. So to now, we had seen some basics of chemistry, and then we learned how to balance chemical equations, right? So today we are going to start the most important topic of this chapter, which will be types of chemical reaction. So how many types of chemical reactions are there? This is the whole crux of this whole chapter. You are studying this chapter just to learn this. Okay. So I'll give you a very high level idea how many types of chemical reactions you are going to learn first, and then we will take up one by one and we will learn them in more detail. Okay, we'll see examples and we'll take up chemical reactions also. Okay, so this is chapter 1, and we are now learning types of chemical reactions. Very, very important topic. So keep your eyes and ears open, listen carefully, try to understand and ask me questions if you don't understand anything. Okay. So the first type which we will learn, it will be called as combination reaction. Combination reaction. We'll go into the details of what this is, but just by looking at it, what do you think it might be about? Combination reactions. Can anyone make a guess? Combination reaction. What do you think will happen in a combination reaction? No guesses? So there will be some compound A, there will be some compound B, and they will combine together to make some compound C like this. So this is a combination reaction. As simple as that, okay? But we'll go into the details later. First, let's see very high level, what are the things which we are going to learn. So first you'll learn combination. And if there is a combination, there has to be a decomposition also. Decomposition means there will be one big compound which will break down into smaller compounds like this B and C. This is just the ulta of combination. Okay. Then we will learn displacement reaction. And displacement, there is a double displacement also. So let's keep it separate. Double displacement. I'll explain what these mean, okay? And most of the double displacement reaction, it has another name also called precipitation reaction. And last, but one of the very, very important types is oxidation and reduction reaction. It's very, very important, oxidation and a reduction. Okay, how many of you are scared by looking at these names? Tell me the truth. Or do you people think it's going to be easy? This is very simple, okay? As the names tell you, combination means some compounds will combine. Decomposition means they will break down into smaller components. Displacement means one thing, something will get exchanged. One part of the atom will be taken up by some other atom, some other compound. Displacement. Double displacement, we will learn in more detail. Oxidation, reduction, we're going to see now, okay? So let's take it up one by one. We will start with combination reaction today. So
thank you. What kind of hiking?
combination reaction. So let's do this from the NCERT book. Start reading from here. Who will volunteer? Who wants to read today? What? No volunteers today?
Sir, can I?
Yes, go ahead.
Types of chemical reaction. We have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You'll study about types of bonds formed between atoms in chapter 3 and 4.
Okay, so this we have seen this enough number of times in the previous few classes. We know that when some chemical reaction takes place, it's not like some atom is getting broken down into pieces or some new atom is suddenly getting created. That's not happening. New atoms are not created, nor the atoms which are there, they are not even getting destroyed. What is happening? Just some atoms are exchanging the bonds. Like in case of that magnesium oxide example, magnesium was alone initially, oxygen was alone, and they made a bond together and they made this magnesium oxide together, correct? So this kind of thing where bonds are broken and new bonds are created. So like in oxygen, it was earlier oxygen with oxygen, but later it became Mg with O, magnesium with oxygen. So this bond was broken and this new bond was created.
Sorry to rejoin again, sir, of some network issues.
That's okay, no problem. So this part, we have seen this enough number of times. So this is what we are going to start actually from this combination reaction, which is one of the types of chemical reaction. Okay, go ahead, start reading. Read this activity also.
Yes, sir. Combination reaction. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature?
Okay. So I want you to make a note of this part, this quicklime and slaked
Sir,
lime.
can you hear me, sir?
Yes, I was able to hear you. Yes, you can stop now, Nitya. So what I'm saying is this activity 1.4, this is about take a small amount of calcium oxide, which is also called quicklime in general normal languages. So remember this name, quicklime is calcium oxide. So this name you should be aware of, okay? You might get questions based on this. Instead of giving you calcium oxide, they may ask you to write some reaction based on just this name, quicklime. Okay, so everybody, from now on, everyone should remember that calcium oxide is. So let's write some notes here. Calcium oxide, what is the name? Quicklime. And what is this? This is calcium hydroxide, the product, what you see. So this reaction, what you're seeing, no, this is your activity 1.4 actually. This reaction is for the same activity over here, this one. So this quicklime, it reacted with water and it gave you slaked lime, calcium hydroxide. Okay, why are we studying this under this topic, combination reaction? Is anyone able to relate? Why are we studying it here? Look at the reaction.
Combining with others.
Yes, see this compound and this compound, there were two compounds in the reactants. They combined together and they gave you one single compound in the product. So they have combined, right? All these things have combined together. That is why this reaction you will fall under the category of combination reaction. Compound A, compound B, they combine together and they give you a third compound, which is a combination of A and B. Of course, the molecular formula will not be exactly same, it will be different, but it's a combination reaction. So that makes sense to everyone?
Yes, sir.
Okay. Go ahead, continue reading from here.
Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. The reaction also should I read, sir?
No, hold on. So you see what is happening? These names you should, I'm repeating this again. These names, you should take it very seriously, whatever names are there, whether it's a quicklime or slakelime, calcium hydroxide, calcium oxide. So all these names you should be getting yourself familiarized with, get comfortable with all those names. And one important thing, other than being combined, this is a combination reaction, things are getting combined together to form one single compound. Other than that, there is one more important thing happening here, releasing a large amount of heat. Anyone knows what kind of reaction that is called? You would have studied this in 9th standard also, I think. Yes, very good. It's called exothermic. Whenever heat is released, that kind of reaction is also exothermic reaction, which releases some amount of heat. So you should remember this example. Remember this example as an example of combination reaction also, and also of exothermic reaction. Okay, because it releases some amount of heat. Okay, so before we go ahead, let me give you a simple definition of combination reaction. If they ask you to write down what is a combination reaction, what would you say? You will say that reactions in which two or more compounds combine together to form a single substance is called combination reaction. And as an example, what will you take? The one just now we saw. Calcium oxide, which is also called what? Quicklime. It reacts with water to give you what? Calcium hydroxide, CaOH. And what is the name? Common name for this? Common name would be slakelime. Scientific name is calcium hydroxide. Common name is slakelime. Same thing for this one is calcium oxide, and this is common name slakelime. Okay. So this one example just now we saw. Can anyone recall of any other example which we had seen earlier, which would qualify as a combination reaction? And a small note.
Sodium plus oxygen.
Say that again. Go ahead.
Is sodium plus oxygen considered to combination reaction, sir?
Yes, we had taken this example in the previous class. So before I write that example, just let me write this quick note over here, because this is also an example of exothermic. Heat is some amount of heat is released over here. Okay, so if you want, you can write it as plus heat also. So making this an example of exothermic reaction. Yeah, so another example you were giving, what was that? Sodium was reacting with oxygen to give you Na2O. Of course, this is also an example of combination reaction. Not only that, we had also seen magnesium and oxygen to give you MgO. We had seen this in earlier examples, right? We can take even more examples like carbon and oxygen. They can combine to give you carbon dioxide. So
Sir,
tell me.
sir, for calcium hydroxide, how do we call that OH bracket 2?
To read it, you just say read it as CaOH whole 2 and you just call it as calcium hydroxide.
Okay.
Yeah. So in all these reactions, what happened? Two at different compounds combine together to form a new compound. That's why they are all examples of combination reaction. So let's take examples which we know exactly the forming of. Let's take up this example: iron with sulfur, which is also solid. They combine together to make this iron sulfide. And of course, one of the most common examples of this would be sodium reacting with chlorine. Give you, can anyone tell me what will these two combine to form? Sodium and chlorine?
Sodium chloride.
Yes, very good. Sodium chloride, NaCl. And what is this NaCl? Why am I?
Salt, sir. Common salt.
Common salt. Okay. So let's read further now. Right, start reading. Kavya, you were reading, right? Continue.
Yes, sir. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction.
Okay. So you can mark this also as a definition of your combination reaction. So if you want, you can write this definition. A reaction in which single product is formed from two or more reactants is known as a combination reaction. Okay. Read this one also. This part.
Yes, sir. A solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the wall. It is interesting to note that chemical formula for marble is also CaCO3.
Okay. So this one is important. You should remember this. What was happening just now? We saw an example of this reaction. Quicklime quicklime combined with water. You mix it with water and you use this calcium hydroxide. Okay, so this quicklime is used for whitewashing the walls. In olden days, they used to use this quicklime. Even nowadays, they also use still it. Okay, so a solution of slaked lime, which is produced in the reaction above, is used for whitewashing walls. Important point, remember it. And this calcium hydroxide, why do we use it? Because after a few days of whitewashing the wall, this calcium hydroxide, whatever we put on the wall, it reacts with carbon dioxide in the air. Air will have some amount of carbon dioxide, right? So it will react, and what does it form? It forms a very thin layer of calcium carbonate. This thing is called CaCO3, calcium carbonate. And remember, this is marble. This is nothing but marble. Marble also has the exact same formula. So when you have a very thick marble, it will be like a big piece of this calcium carbonate. But here on the wall, this is just a very thin layer of that marble. That is why it is shiny. Thin layer of calcium carbonate is formed, which is shiny. That is why this is used for whitewashing the walls. So there were, yeah, anyone has anything to say?
Yes, sir. Like in the reaction where in the textbook, sir, they have given the states of the compound. So for calcium hydroxide, it is aqueous, and for H2O, they have written L. So both are same, no, sir. If we like change
See,
using the
H2O is like pure liquid. It's not mixed up with something, no? That is why you write it as liquid. Even some other compounds may be purely liquid, not mixed with something else. So now this calcium hydroxide, when you write, this is a different compound. Why do you write aqueous? Because you have mixed it with water in the previous case. When you did this reaction, you mixed it with water and you formed an aqueous solution. Means calcium hydroxide is mixed up with some amount of water. That is why this is aqueous.
okay.
Okay. So this reaction is also very important. Remember it. What was the reaction? Anyone can remember? Slaked lime. What was the formula?
CaOH whole 2.
CaOH whole 2. This was your slaked lime, which how did we form it? By mixing quicklime with water. Calcium oxide with water. We made this compound, which is aqueous. And this reacted with the carbon dioxide in the air to form what compound? What was the formula for the marble, which I said?
CaCO3.
CaCO3. This is nothing but calcium carbonate. Okay. And this is shiny. That is why it is used for whitewashing. Okay. One extra information from this reaction itself. You see, whenever you have a compound, something CO3, like here you had calcium CO3, right? CaCO3. So this CO3 basically, this is the one which is called carbonate. Okay. So it could have been calcium carbonate or magnesium carbonate or something else depending on what this CO3 has bonded with. So in this reaction, of course, this is calcium carbonate. Remember this part CO3, this is what is called carbonate. Okay. Just the name I'm talking about. Wherever you see CO3, you should think of carbonate. Some carbonate. You'll understand why am I saying this when we go through more examples of reactions. Okay. All right. So combination reaction is clear to everyone.
Yes, sir.
Okay, fine. So we still have some time. So I want someone else to start reading this part. Who will read?
May I, sir?
Okay, go ahead. But boys, nobody volunteers. Do you people not want to read? Okay. Nitya, go ahead. Read this.
Yes, sir. Let us discuss some more examples of combination reactions. Burning of coal.
Yeah, you can read.
C plus, uh, may I read the reaction, sir?
Yes, read it.
Carbon plus oxygen, which gives us carbon dioxide. Hydrogen plus oxygen, which gives us
Water.
H2O.
Yes, this is H2O, which is water. Okay, stop for a
Water.
moment. Yeah. So
In a simple language,
1 minute. Hold on. So these examples are very simple, right? When I'm saying burning of coal, coal is made up of carbon, right? That's why when they say burning of coal, they are making the reaction with carbon because coal is made up of carbon. Now, whenever we say burning, I had said this in your previous classes also, burning means reaction with oxygen. Keep this idea in your head very clearly. Whenever you burn something, basically you are making it react with oxygen chemically, okay? So burning of something means making it react with oxygen. So burning of coal will be carbon plus oxygen and it will form your carbon dioxide. And same way, hydrogen and water, oxygen, these two are gases, and we had seen this reaction earlier also. They combine to form water. Yes, go ahead, Nitya. Keep reading this.
yes, sir. In simple language, we can say that when two or more substances, that is elements or compounds, combine to form a single product, the reactions are called combination reactions. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of the products are called exothermic chemical reactions. Other
Yes.
examples of exothermic chemical reactions are burning of a natural gas.
Yes. So this exothermic reaction, this is also very important part of this. So what is that? A reaction in which heat is released along with formation of products. So that reaction will be called exothermic. So right, you will make note of this definition also in your NCRT, the tuition note. Okay. So let me write that for you. What is the definition? A reaction in which heat is released along with formation of products. Examples. Just now we saw one example would be Ca calcium oxide plus water, which gave you CaOH whole 2. This example we had already seen. You can write it as plus heat also. Then another example they are giving here, burning of natural gas. So what is a natural gas? Chemically, the natural gas is CH4. Anybody knows CH4 name, scientific name for it? Chemical, what kind of chemical compound it is? CH4. I had used this name in one of the previous classes. Anyone remembers?
Compost gas.
Say that again.
Compost gas, sir.
Actually, that is also the same thing. When you compost something, there also the same thing is formed. This is called methane, CH4. Okay, it's called methane. You'll learn more about this in the carbon and compound chapter, but that's okay. Okay, so burning of natural gas, you are actually making methane, the CH4, react with oxygen. Burning of coal was what? Carbon with oxygen. Burning of natural gases, methane with oxygen. So CH4, which is a gas, burning means we are making it react with oxygen, of course, chemically. And then what is formed? When something burns, carbon dioxide is very bound to form most of the times. If there is enough amount of oxygen, then carbon dioxide will be formed, especially if it is a carbon compound. And then some amount of water is also released. So why is this water written as gas? Should it not be liquid?
Released in the form of vapor.
Yes. So whenever you see H2O, but it is written as gas, it means it is steam. Because you know this is heating up or burning something. So of course that water, whatever is there in small amount, that will get converted to gas. It will be a steam. Also remember, make note of this point, respiration. When we breathe in the thing, that respiration, whatever happens within our body, that part is also exothermic reaction. That also releases some amount of heat. Respiration is also exothermic. So this could be a 1 mark question in your some of your exams. Okay, so I have not balanced it. So let me write the balanced chemical equation, 2 of oxygen and 2 of H2. So we have done enough examples of balancing reactions. So whenever you see something, it is your duty now, from now on. You will see whether the reaction is balanced or not. If it is not balanced, you will make it balanced. Okay. Go ahead, read Nitya after this.
Yes, sir. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contains carbohydrates. These carbohydrates are broken down into to form glucose. This glucose combines with oxygen in the cell of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in chapter 6.
Okay. See, they are talking about respiration over here, but why is this? What is this glucose doing over here? And energy? What all that has to do with the respiration? Anybody knows? Has any idea about why they are talking about all this? So far, you would have thought that okay, respiration means oxygen is there, that is getting converted to carbon dioxide. Correct? That is what you think.
Sir, for the lungs to work, it needs energy, so the blood gives energy in the form of glucose.
Okay, so you are close, but I mean, this is a biology part. You will study this also. We will study this reaction also basically in biology when we take up that chapter. So what happens is why are we breathing first of all? Why do all these living organisms breathe? Why do you think we need to breathe?
To stay alive, sir.
Okay, if we don't breathe, we will die. We know, but why did our body adapt to learn? What is the whole point of breathing?
We need oxygen.
Okay, we need oxygen. We eat food also. We take up all that food, we digest it, and then we breathe in some air, oxygen from that. So all that food, whatever gave you your glucose, food gives you glucose. And when we breathe in oxygen, that oxygen reacts with this glucose and gives you the energy which is needed for each and every cell in our body. So this energy, it is not only for the lungs. This is the whole thing. This is the whole reason of doing whatever all these living organisms do. You eat food, get your glucose, you breathe in, you get your oxygen, and then respiration. That's what this process we call as respiration. That is where we are doing all that to get this energy, because this energy is needed for each and every cell in our body, not just for our lung. Okay. This is the source of energy for all living beings. Carbon dioxide, this is just a byproduct which we breathe out. some amount of vapor is also released in that process. So when we breathe out, if you keep some glass near your nose, when you breathe out, you will see that some amount of vapor will be there on that glass. That is a result of this reaction. Okay. So respiration is not only for taking in oxygen and releasing out carbon dioxide. Carbon dioxide just is a byproduct. The whole thing we are interested in is the energy. This energy is used by each and every cell in our body. Okay. So we'll see that in more detail in biology. Let me not get too excited about it. Sometimes I get excited because these things are very fascinating. How the human body evolved to take up food, then digest it, and then make it react with whatever oxygen we are breathing in. And not only that, all that energy or all that whatever glucose we, not only glucose, all other proteins and whatever things we eat, all that is transported to each and every cell in our body, billions of cells. How all that happens. That's very fascinating. Okay.
May I read, sir?
Yes, go ahead.
Yes. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Identify the type of reaction taking place in activity 1.1, where heat is given out along with the formation of a single product.
Okay, so what are the examples we saw?
Decomposition.
No, stop there. Decomposition we'll see in the next class tomorrow, okay? So I want you people to read this on your own also. Whenever you have it, because we have gone through this, most of the things you already know, it will barely take you 10 minutes to go through all this again once more. But I want you to do that, okay? While you have this note open with you, whatever I have written here, all these examples and definitions. So revise it once more later tonight, and this information will get consolidated in your mind. Okay. So some examples of exothermic: burning of natural gas, respiration, which is what is a respiration reaction? This is the one. This is a reaction for respiration. Try to remember this also. So if somebody asks you to write down the reaction for respiration, that's the reaction you will write. C6H12O6, and it reacts with what? Oxygen. Give you. Okay, this oxygen is also in the aqueous form. It has mixed up with all the. Right, so C6H12O6, O2. This gives you carbon dioxide, water, and energy. So you will take up this reaction from here. This is also aqueous. This is liquid, of course. Balance the equation. 6 and 6. 6 molecules of this. 6 molecules of each of them. So this is your reaction for respiration. And then decomposition of vegetable matter into compost. This is also an example of exothermic reaction. So I'll give all those reactions later in the note when I share. But for now, go through all these things, all these examples. I want you to be very comfortable, familiar, and try to memorize now itself, how much ever you can. Okay, anyone has any questions from today's class, whatever we discussed?
No, sir.
Okay, fine.
Sir, the vegetables being decomposed, like how is the heat produced?
See, whenever some reaction decomposition happens, how is the heat produced means that is just part of a reaction. Heat will be produced, but don't think that it will be so much heat that you will be able to feel it. The amount of heat released over there is very small. So things may get warm a little bit if you touch this place where this compost is being created, the temperature may be slightly warmer over there. You can feel it if you touch that soil. You know how composts are created, right? All these food wastes, they are put up. You can dig a hole in and put those vegetables or food wastes and then cover it with some amount of soil. You put a little bit of water also, and that reaction, whatever creates that compost, that is exothermic. And it's a little hard to explain why it happens, but yeah, some amount of heat is created. It's not so much that you'll get hurt by that. It's very small, warm. You can feel that it will be a little bit warm. Okay, so I'll see if I can find a reaction for this one, but that's not part. You don't have to know the definition, the what is it called, the chemical formula, what is happening in this compost. Okay, because food particles, what you see, the compost can be created from so many different kinds of food, and food is a very, very complex thing. The chemical formula for that is going to be very complex. That's why you do not have to study that, this reaction. Just know that it is one of the examples of exothermic reaction. That's more than enough. Right? Any other questions? So if there is nothing, then let's finish the class today. That's it for today, guys. Yeah, go ahead.
Sir, I have a doubt from Max.
Maths doubt.
Yes.
Maths doubt. Is it something urgent? You have to show this in your school or anything?
Yes, sir. First chapter, sir.
Okay, go ahead. Tell me.
Sir, they gave one theorem, sir. Root 2 is irrational.
Okay. Fine. So
Prove that root 2 is irrational.
yeah, I know that's a completely different type of question. I have to still teach you that thing. So what I will do is, do you need to show this tomorrow in school?
Yes, sir.
Okay. So just drop a message in WhatsApp. Okay, I will send a solution to you for this,
Okay, sir.
and I'll explain it in more detail tomorrow. Okay. Today I'll just send you the
Okay,
solution.
sir.
All right. Any doubts from science, whatever we discussed today?
No, sir.
All right then. Bye. See you all.
Thank you, sir.
Thank you, sir.